Welcome to Cocos 2D Tutorials, brought to you by Bob Euland. For more information, go to bobuland.com/cocos2d. In this tutorial, you will learn how to use the accelerometer. The iPhone, iPad and iPod Touch can sense their environment thanks to some built-in instruments. There is the accelerometer, which measures the gravity and the rotation with respect to the gravity, and also the user acceleration, which can be used to sense if the user is shaking the device. There is the gyroscope that measures the rotation rate with respect to different axes. And there is the magnetometer that measures the angle to the Earth's North Pole. But all devices do not have all the instruments. This table illustrates what devices have what instruments. For instance, the simulator on your Mac does not have any instruments at all. But all the other devices have the accelerometer. When it comes to gyroscope, only iPhone 4, iPad 2, and iPod 4G have it. When it comes to magnetometer, we see that iPhone and iPad have it, but no iPods. This slide shows how we can rotate our device along 3 different axes. We can rotate it along this axis, and that is called pitch. Along this axis, it's called a roll. And along this axis, it's called yaw. The normal accelerometer can sense the pitch and the roll, but not the yaw. When the gyroscope was added, then also the yaw sensing became possible. Now a lot of applications do not need the yaw. In fact, it is very difficult for the user to control 3 rotations at the same time. But some applications do need the yaw. Now, how do we access the data given by the instruments in our code? If we use UIKit, we can use the UI accelerometer. But we will only get the pitch and the roll. If we also need the yaw, then we can use core motion. And instead of UI accelerometer, we would use CM Motion Manager. If we use UIKit, we will use this method. Accelerometer did accelerate. To get the roll, we would use acceleration.x, and to get the pitch, we would use -acceleration.y. If we use core motion, we would access the data in this way. We would extract the attitude and use that to get the roll, the pitch and the yaw. In this tutorial, I will provide 2 different sample projects, a UIKit version and a core motion version. But in the screencast, I will only go through this version. The core motion version you can look at yourself. But observe that you must add the core motion framework to it. One important observation is that the instruments provide data of how the user is moving the device. It does not tell you what to do with that data. You can use it to generate music, move a spaceship, move an external camera, or perform surgery. It's really up to your ingenuity. Let's now go to Xcode and see how to use the accelerometer. We are inside Xcode, and our task is to make a spaceship move in X and Y direction using the data from the accelerometer. Our plan is to enable the accelerometer by setting the property is accelerometer enabled to yes, and then trap the system message Accelerometer did accelerate, and take the data given by accelerometer and use it to move the ship. Let's begin by looking at our starting point. We have an image called ship.png and an image called background.png. In our interface file, we have two instance variables, a size called vinsize and a sprite called ship. In the implementation file, we first set the background image and then the ship. We are also defining the vinsize, which we later use to prevent the ship from moving outside the iPhone screen. Let's run this. As you can see, we have a background image and a ship. What we want to do is to physically move our iPhone and extract the accelerometer data so that the ship moves on the screen, vertically and horizontally. Stop. Let's go to the interface file and write some code. Paste some code. We introduce two instance variables, ship speed y and ship speed x. We will use these variables as containers for the data coming from the accelerometer, and then we will use the data to position the ship. Let's go to the implementation file, the init method. Paste some code. The first thing we do is to enable the accelerometer by setting self.isAccelerometerEnabled equals yes. And that will of course cause the system to start sending the accelerometer did accelerate messages to us. The rate is device dependent, but it will probably be something in the order of 60 times per second. The second thing we want to do is to call schedule update. Now let's paste some code. Here is the accelerometer did accelerate method, and our data is in the acceleration parameter. There will be x, y, and z data, but we will only use x and y. Now acceleration.x refers in our case to the y-axis, since we have our iPhone in landscape orientation, while the accelerometer by default is assuming the portrait orientation. Now to make the movement a little larger, we'll multiply by 10. We are also adding a constant, and this constant governs the zero tilting angle. If this constant was 0, then the default position of the iPhone would be flat. And we don't want that, because the user normally holds the device in some angle, like 45 degrees. That is when he's sitting in a chair. If he was lying in the bed, the tilting angle would be more like 90 degrees. And in that case, this constant would be even higher. In fact, it would be a good idea to let the user choose which tilting angle he prefers by letting him change this constant in some setting scene. The y component we only have to add a minus sign to, so that our ship moves in the desired direction. Now that we have the ship speed y and ship speed x, we can use it to move the ship. We call the update ship from the update method. In the update ship, we take the old y position and add the ship speed y to it. We also make sure that we are not outside the window. And likewise for x. And then we set the new position to new x and new y, and we can run it now. And as you can see, I can control the ship's movement by tilting the device in various directions. Thank you for watching.